Sorry.
Alles gut.
Ja, ich bin jetzt wieder so auf diesem Ding drauf, ne?
Ich habe mich damit selber auch noch nicht genau.
Komisch.
Ich habe hier kriegt man, glaube ich, die Agenda.
Ja, und wenn ich jetzt sozusagen, da unten ist das Messages ja hier.
Okay.
Ja.
Aber ich muss hier jetzt weitermachen.
Ja, Entschuldigung.
Kein Problem. Ist nur heute ein bisschen eng alles. Habe ich denn schon jemanden hier? Ja, ich habe aber meinen Moderator noch nicht hier. It's you. Okay. You can come up here. You're the moderator for this session, right? Yeah, you can come up here and moderate from here. We have the camera and everything. Yeah. So that'll be easier.
Sit here, right?
Oh,
like
I will stay here because I will
start
the presentations for you.
so I can sit here maybe?
Yeah, or you can take another chair here, whatever feels good for you. And then I will also include video. So it will be visible for the others. And then I will that is for you.
Okay.
Or do you prefer the let's say?
I think it would be great.
Okay. On. Perfect. Okay.
Yeah.
Go ahead, yeah.
Thank you all audience. I mean, just people who are following this online poster presentation. And our session is mainly on terrestrial and aquatic ecosystems. And we will have 7 poster presenters here. And first, let me introduce myself. I'm Hafta, and I work at the University of Natural Resources and Life Science, which is Bock University. So I'm going to chair this session for the next 45 minutes. So maybe I can just proceed to the next presenter, but I have some instruction just to share you. First, please introduce yourself and tell us your affiliation. And there will be 3 minutes presentation. And if we have time, we will have time in this questions and discussion 2 minutes. And you will finish within like 5 minutes. That will be our instruction. So now I will invite Lena.
Yes.
Please, you can continue.
Are you going to play the one I recorded, or should I present it?
If your connection is okay, I think can allow you to present directly.
Okay, so I'll have to share my screen.
Yes.
Okay.
But I also have videos. Either way.
Yeah, I think it's easier if you just play the video, and I'm open for questions after that.
Okay.
Thank you. Dear listeners, my name is Lena Krieger, and I welcome you to my poster presentation about biocultural diversity in traditional and modern agroforestry systems in Togo and Benin. The research presented is a first exploratory study within the framework of my PhD research on agroforestry in Togo and Benin. I chose the concept of biocultural diversity as it offers a novel opportunity to improve the understanding of traditional and modern agroforestry systems, taking into account social and ecological aspects. The study is carried out across the different agroecological zones of both countries. The aims are to inventory and characterize these systems based on case studies covering different climatic and ground conditions. Due to the complexity of this topic, I chose a mixed method approach, including interviews and site surveys, database research, and remote sensing. Research showed that conversion of cropland or pasture to an agroforestry system is the modern way, while thinning of existing forests to allow agricultural production is the traditional way of implementing agroforestry in Togo and Benin. Looking at structure, tree composition, and crop association, I found that elevation, precipitation, and sociocultural preferences of ethnic groups are the most important factors. Introduced tree species play a significant role. Long-established non-native tree species are single-purpose trees focused on firewood charcoal production, whereas recently introduced tree species are single and multi-purpose trees focused on ant fixation, soil improvement, afforestation, and shade provision or on fruit production. More recently established linear or multi-story agroforestry systems are focused on growing cash crops. There is considerable variation in alpha diversity among the study sites. Biocultural landscapes that are highly specialized, such as the Kabylie Mountains, have an exceptional diversity of trees coupled with a relatively low density compared to multi-story systems. Tree diversity and species composition are linked to ecological and social factors. In summary, it can be said that long-established systems focus on subsistence farming and sociocultural functions, whereas recently established ones focus on production for sale. It is important to further study the biocultural complexity of these systems to optimize climate change adaptation, which I'm going to do in my further PhD studies.
Thank you, Lena, for your nice presentation. We have 1 minute. If there is any question from audience, that's it. Any question, comment? Okay, if we don't have, just thank you, Lena. So the next presenter will be Afi Amen. Afi Amen.
Yes, I have. Oh no, it's only audio. Are they present?
Okay, so the audio.
No, they are not in the meeting either.
Oh, okay.
So we skip to the next one.
Yeah. So the next will be Jonas.
Yes, hello. I will share my screen.
Okay.
So I cannot share my screen.
I will give you powers.
Wait. Now you can share your screen.
Okay, thank you. Okay, so hello, my name is Jonas Steinfeld. I am affiliated with the University of São Paulo in Brazil and Wageningen University and Research in the Netherlands. I'm currently in Brazil. It's 4:30 here, so I'm a bit early, but I will present. My research, this was part of my PhD research actually, which I concluded at the beginning of this year. It's about agroforestry in Brazil. The title is Scaling Complex Agroforestry, Constrained by Labor Demand. This is a collaboration between Wageningen University and the University of São Paulo. We also have researchers from Embrapa Environment and a number of pioneering farmers who participated. The context is that, well, it's well established that agroforestry systems are more complex than monocultures, and they also provide more ecosystem services. However, it's often postulated that this also requires more labor. And in a world where labor is increasingly scarce, it's very important to assess whether higher agroforestry complexity indeed increases the labor demand. And so that was also the objective of this study, to assess these relationships between the complexity, the degree of complexity of an agroforestry system, the labor demand, and soil-based ecosystem services. And the second objective was to assess what the implications of these relationships are, as perceived by farmers, for scaling these systems. We took a subsample of a larger sample. So the larger sample was 30 agroforestry systems. We took a subsample of 10 systems that represent a complexity gradient in terms of diversity, density, and management. And we selected these also based on whether they could provide high quality labor data. And then we quantified the labor inputs for fertilization, weeding, pest control, crop management, biomass management, and harvesting, and compared these also to reference monocultures. We also conducted workshops with the farmers. And what we can see in the results, we'll zoom in here, is first of all, we had two types of agroforestry systems here, multistrata and successional agroforestry. Successional agroforestry being more complex. And we can see a general increase in complexity if we go from the left to the right, okay, amongst these 10 systems. And what we can see is that successional agroforestry systems had significantly higher labor demand than the multistrata systems. So the more complex systems required more labor, but we also found that they had significantly higher levels of ecosystem service provision. So looking at available water capacity, phosphorus, cation exchange capacity, and organic carbon stocks. We also saw that all of these successional agroforestry systems required more labor than monoculture references. But if we look at the less complex multistrata systems, we saw that actually 4 out of 6 required less labor than the monoculture references. So we could see that not all agroforestry systems actually require more labor, but that the more simplified systems could actually require less labor than monocultures. In the successional systems, we saw that most of this labor increase actually came from managing biomass. So that includes pruning, mowing, and mulching. And in fact, they actually spent less time on weeding and pest control than monocultures. But the increase in this biomass management was so big that overall they require more labor than multistrata systems and monocultures. And if we look at the challenges that farmers themselves identified and rated as how severe they are for them, we can see here in this graph on the bottom half challenges at the field to farm scale, such as efficiently processing pruning and mowing residues, or pruning, or having machinery suited for dense agroforestry. And in the upper half, we see more regional to national challenges, such as having labor availability, access to land, or competing with conventional products in the market. And here we can see two patterns. One is that the more complex systems, they faced, or they rated also the challenges at the field to farm scale as more severe, whereas the less complex systems didn't see that as a big problem. But when it comes to these regional and national challenges that are somewhat out of their control, then all agroforestry farmers perceive these as quite severe. That shows that actually there are some systemic threats and problems.
Sorry, you are.
Yeah, thank you. That's basically it.
Yeah, I'm going to stop you, okay? Thank you. So,
Stop sharing. Yeah.
since we don't have time, maybe if there is any question, you can maybe send him directly on private chat or like also group chat. So we will proceed to the next presenter, Maria.
We have the video, so I'll just play that.
Maria,
My
are
name is
you?
María Gustavo Bermejo.
Maria, are you in?
No, I don't see Maria here. So I'll play the video.
Okay, yeah.
So I am here. Everyone, my name is María Gustavo Bermejo, and I am going to present my research evaluating drought management strategies in Andean irrigation systems. In the Ecuadorian Andes, approximately 70% of the rural population relies on agriculture and livestock for their livelihood. Prolonged droughts have severely impacted these activities and causes significant economic, labor, and social impacts on communities. The lack of a monitoring irrigation systems caused farmers to make decisions without information. The scarcity of information about irrigation has decreased production. In this context, using soft information is a key approach to evaluating drought management strategies in Andean irrigation systems with limited data. About methodology, I consider three aspects. First, precipitation analysis to get critical precipitation.
I don't think I'm sharing the screen right now. That is my bad. Now it should work. I will just go back.
My name is María Gustavo Bermejo, and I am going to present my research evaluating drought management strategies in Andean irrigation systems. In the Ecuadorian Andes, approximately 70% of the rural population relies on agriculture and livestock for their livelihood. Prolonged droughts have severely impacted these activities and causes significant economic, labor, and social impacts on communities. The lack of a monitoring irrigation systems caused farmers to make decisions without information. The scarcity of information about irrigation has decreased production. In this context, using soft information is a key approach to evaluating drought management strategies in Andean irrigation systems with limited data. About methodology, I considered three aspects. First, precipitation analysis to get critical precipitation using historical data. The second one, the community participation, considers two parts. The first one with the system operator to getting a discharge reconstruction and joining it with critical precipitation and proposing drought scenarios. With farmers, I did surveys to obtain information about the strategies that they use in critical conditions. The last one is a review literature to get the strategies that people in the world are proposing. Finally, I used the scenarios and strategies identified to evaluate drought management results. 24 strategies were identified, and I used an adaptation of the Eisenhower matrix to select strategies that have a high impact and need low effort to implement in the Ecuadorian Andes. It results in 6 strategies selected, described here. The strategies evaluation considered the 6 selected and 2 drought scenarios. 6 selected strategies and 2 drought scenarios. Less water demanding crops, installation of reservoir tanks and irrigation shifts were the best results and caused more impact regarding adaptation to drought periods. The scenario with critical precipitation showed better results compared with the other. Conclusions. A combination of soft data, modeling, and farmers' participation is essential to generate sustainable solutions to droughts. Effective drought management in the Andes requires combining local practices, modern technology, and strategic planning. Assessing the viability of strategies in terms of their technical, financial, and expertise sustainability is essential to ensure this long-term success. Thank you.
I think if she's not, online. Anyways, yeah, thank you for her video poster presentation. And now I'll proceed to the next presenter, Yasmina. Yasmina.
I saw her join just a minute ago. Hello, is she? Yes, she's here.
Yasmina, are you going to present direct from your PC or a video?
I think we have the video. Let me check. Oh no, we don't have a video for that one.
Okay. Let me skip.
I sent her a notification. Maybe we take the next one and
Yeah.
go back if we have.
Yeah. So I will skip this presenter. So I will now invite Lakshmi from India. I can see. So you want to present from?
Yeah. Yes, I'm here.
Okay.
Can you hear me?
Yeah, we can hear you. If your connection is good, you can present from your PC.
So
Oh, yes. Go ahead.
And you.
So can you hear me now?
Yeah. Now I'll share your screen.
Okay, thank you. So good morning all. My name is Lakshmi and I'm working as a postdoctoral fellow at National Center for Aquatic Animal Health, Cochin University of Science and Technology, Kerala. So we have done a study in the home gardens of Kerala, India, to assess the response of earthworm towards a catastrophic flood event. So as we know, earthworms help in carbon cycling and have an important role in soil food webs. And in our study, we have identified an industrial area which was flooded. All the home gardens were flooded. There were total 25 home gardens. And the zone was divided into three, that is zone 1, zone 2, and zone 3 for ease of sampling. Zone 1 was very proximal to the industries. Zone 2 a little bit distance, that's about 10 to 15 kilometers from the industry, and zone 3 more than 20 kilometers from the industry. So we can say that zone 3 was a non-industrial area, while zone 1 was totally an industrial area. We have put forward two hypotheses. The first one was that floods can impact the species distribution, abundance, and life cycle stages of earthworms in an urban area. And second was that earthworm population are resilient and can recover after a flood event. So here you can see the study area in which we have done the work. So for the study, we have collected the soil samples and also the earthworm samples. The soil texture and soil properties were determined. Also, the earthworm abundance was taken. The abundance was determined at two levels. That is, we have sorted the earthworms into two, juveniles and adults. Separate abundance were taken and total abundance were also taken. The earthworm abundance was estimated before and after flood during summer and northeast monsoon in 2018. This flood has happened before northeast monsoon of 2018. So we have done a comparative study before and after flood. The statistical significance was estimated by ANOVA. So we could find that the soil texture in the study area varied from sandy to sandy loam, and all the home gardens were flooded in the region. Again, we could find by observing the earthworm population in three zones. So the post-flood earthworm community comprised of 6 species, and these species were same as those found before the flood. Destroy any single species, but only the abundance was affected. So here we could see the distribution of earthworms. This Pytholus cotrusus, it was an invasive species. It was present more than half of the home gardens, and other species of earthworms were distributed in the home gardens. Dravida impursuta was absent in zone 1, and Megascolexus concanensis, which is an endemic species, it was absent in zone 3. Dicogaster borlai and Megascolex cochinensis was present only in zone 3. So here this chart shows the comparison of earthworm abundance in through three zones in the zone-wise level. We could see the zone 1, which is proximal to industrial area, it had the lowest abundance, while the zone 3, which was very much distant from the industrial area, it had the highest abundance. So while observing the abundance of earthworms in the home gardens, we could find out that the juveniles and adults in zone 1 were affected compared to that of zone 3, and equal share of juvenile and adult abundance between abundance immediately following flood and the post-flood abundance by statistical analysis. So effect exhibited by flood on earthworm abundance, earthworm species. Flood, and they had, yes?
Can you go directly to your conclusion? You are running out of time.
Can you hear?
Go directly to your conclusion. Can you hear me?
Yeah, I can hear you.
I'm calling with it hearing you. Right. So anyways, thank you for your presentation. We will proceed.
So can
Okay, so who's next?
So the next presenter will be Abenan. Abenan, are you?
I don't see your.
Yes.
Yes. Okay.
Ada.
So she has video or?
You can share the video.
Okay, you want to present directly from your PC? Okay. Okay, perfect.
Yes.
So you can share your screen now. It's working. Yeah, for us it's working. You can continue.
Okay.
My name is Abeno Leontine, and with my co-authors, we present the poster entitled Restoration of Soil in Rwanda and Cocoa Landscapes in Côte d'Ivoire. Soil quality is reduced in humid and sub-humid areas in Côte d'Ivoire due to extensive agriculture. This study aimed to assess rubber and cocoa plantation contribution in soil quality restoration based on evaluation of the relationship between associated tree diversity and soil physico-chemical parameters in 24 land plots of 2 study areas. The result that 5 associated tree species were recorded in rubber plantations, while cocoa plantations home to 38 associated tree species, with 4 species having special conservation status. Physical parameters of soil show that soil bulk density decline with increasing age of rubber plantations, while meanwhile diameter increases until the 15th year of cultivation. In cocoa landscape, physical chemical does not change. These results show that rubber plantations improve the physical structure of soil to a third floor level. As for cocoa plantation, they maintain the structure of soil after forest conversion. Concerning chemical parameters, soil pH decreased with increasing age of rubber and cocoa plantation. Also, exchangeable trays contains increase with increasing age of rubber plantations, with carbon content increase in cocoa plantations, or state the highest diversity of associated trees. Also, the principal component analysis relate a strong positive correlation between the diversity of tree associated with crop and the soil carbon, nitrogen, and phosphorus content in the rubber landscape. In the cocoa landscape, a weak positive correlation was noted between vegetation and soil parameters. These results revealed that chemical quality of the soil under rubber plantation is preserved during farming due to the contribution of rubber tree in mesophanerophyte species, while tree diversity contributing in restoring soil under cocoa farming, cocoa are fertile. At the end, we note that the presence of trees is essential for maintaining soil quality. The guava tree as mesophanerophyte species contribute to soil quality restoration. Also, cocoa farming as agroforestry system contributes to soil restoration. Adopting agroforestry in all cropping systems would be beneficial for restoration of natural soil reserves. Thank you for your attention.
Thank you, our I think last presenter, Benin. But still, if Yasmina is, I don't know, in the meantime we can just allow her to present.
She was in earlier,
Yasmina?
but I don't see her right now. No, I think she left.
Internet connection. Okay, I think, yeah, we couldn't find her also in the online. So thank you so much, all presenters. And now we have, yeah, almost 20 minutes just for discussion because we have time until 10:30. So if you have any question, you can post here, and yeah, we have also comments, also maybe additional information on the poster presenters, like they can just add any point. So yeah, we're just looking forward for your questions. My start, maybe I have just one question to the last presenter, to Abenan. On your conclusion, just I saw one point, just conservation of bulk density. What do you mean? Like, can you please briefly explain?
Can you repeat your question, please?
Pardon?
Repeat the question.
Okay. On your last slide, the conclusion part, just I saw a point, just one of the advances, like conservation of bulk density. So what do you mean, conservation of bulk density? You mean just to improve the bulk density, or what?
Okay. We say that agroforestry system can conserve, I can say, soil quality and all, because when we studied many farms, we saw that we use forest as I can say a true a control. Okay, I use forest as control system, and we saw that all parameters that we study in forest stay the same in forest and all farm system, cocoa farm system. So we can say that cocoa farm system or agroforestry system can conserve all soil quality along these land gradients, land use gradients.
Okay, so maybe just I can add one point here. I'm also agroforestry by profession, so I mean maybe it's because of your wording or your explanation. So rather you better to say like the advantage or the contribution of agroforestry for decreasing the bulk density instead of like increasing, it would be like decreasing the bulk density, increasing the porosity, increasing the cation exchange, all this, physical and chemical soil characteristics. So this would be more the advantage. So instead of like conserving the bulk density, you have to say maybe decreasing or reducing the bulk density, or increasing the porosity or air exchange or microbial activity, all these things. So you better to incorporate these pointers on your last conclusion, okay? I'm already satisfied from this side, so maybe I can give for other audiences. Is there any question? Any comment, any question?
It's to me.
No, not only to you, I mean to all presenters. Yeah.
Okay, okay, thank you.
But, so I think if we don't have any question or comment or point to discuss, I think I will close the session. So thank you again for your participation and for your contribution. Please try to follow also the other sessions. We have also other presentations like related with agroforestry and also other thematic areas. Please stay tuned and thank you again. Yeah, there are also some, I don't know, tomorrow workshops in case if they are going to be streamed online. Please try to follow also these sessions. Thank you so much. Have a nice day. Thank you.
Thank you.
Thank you.